Good day, everyone! For this video, we will talk about one of the basic integration rules, which is the power rule for integration. The power rule of integration is used to integrate functions with exponents. In terms of a variable, let's say x, then it is used to find the integral of powers of x. The power rule says that the integral of x raised to n dx is equal to x raised to n plus 1 over n plus 1 plus c, where n is not equal to negative 1. To apply the power rule of integration, the exponent of x can be any number, positive, 0, or negative, just other than negative 1. Now, let us learn how to derive and apply the power rule of integration along with many more examples. For our example number 1, we have the integral of x squared dx. In applying the power rule, we simply add 1 to the exponent and we divide it by the same exponent. So in this case, having the integral of x squared dx, we will have x squared plus 1 over the same exponent, which is 2 plus 1. After that, we add the exponent. 2 plus 1 is 3, and for our denominator, which is also 2 plus 1, it will also have the sum of 3. Take note that in finalizing your answer, you should never forget the arbitrary constant to the final answer, which is denoted by letter C. Next, we have the integral of g dg. In this case, you might be wondering why am I trying to integrate this integral when it doesn't have any exponent. You cannot see any exponent, right? But the truth is, g has an invisible exponent which is equal to 1. Applying the constant rule, we will have g raised to 1 plus 1 over 1 plus 1. Then it will be equal to g raised to 2 over 2 plus our arbitrary constant, which is letter C. As simple as that. For our third example, we have the integral of x raised to negative 4 dx. Just like what is told a while ago before discussing different examples regarding this rule, it is said that we can have any number as our exponent even if it is negative except negative 1. So we can use the power rule to integrate this given integral. X raised to negative 4 dx. Adding 1 to the exponent, we will have negative 4 plus 1 as well as our denominator. X raised to negative 4 plus 1 is 3. For our denominator, we will just copy the exponent and then add c. So, our final answer will be x raised to negative 3 over 3 plus c. Number 4. We have the integral of square root of k dk. So, the integral of square root of k dk is equal to k raised to 1/2 plus 1 over 1/2 plus 1 plus c. K raised to 1/2. You may be wondering where 1/2 came from. So, as you can see, there is no more radical sign in our solution. It is because 1/2 is equal to our square root. Moving on, 1/2 plus 1 is 3/2 over 3/2 plus the arbitrary constant. After that, we will multiply k raised to 3/2 to its reciprocal, which is 2/3. So, our final answer will be 2k raised to 2/3 over 3 plus c. Finally, for our last example, we have the integral of f raised to 7.2 df. So, just like the previous examples we had, all we have to do is add 1 to our exponent. So, f raised to 7.2 plus 1 over the same value of our exponent, which is 7.2 plus 1, we will have f raised to 8.2 over 8.2 plus c.